They are a one-way street. You go in, and nothing escapes, not even light. In Sagittarius, there is a black hole that weighs 2 to 4 million times the mass of our Sun, and we on Earth are actually moving around that black hole. If you thought you knew what black holes are, prepare to have your mind blown. There's just no good end to anything that falls into a black hole. There's a lot more that happens in those things up in outer space, and fascinating new details are being revealed to this day. More recently, researchers in Russia have made some of the scariest discoveries ever. Join us as we unravel what Russian scientists discovered inside a black hole that terrified the whole world. Black holes and how they form. The common, more fictional concept of black holes is that they are some sort of portal to another dimension. This has been proven wrong many years ago, and what scientists have discovered may send shivers down your spine. According to researchers at NASA, black holes are mysterious entities of space with a gravitational pull so strong that even light can't escape. Something that scientists thought was impossible turned out to be true in 1915 when Carl Schwarzschild found the solution to Einstein's equations predicting the phenomena of black holes. But it wasn't until later in 1964 when Cygnus X1 was discovered, and something that was just a theory turned into a physical entity that revolutionized astronomy. Cygnus X1, this special black hole, is 15 times heavier than the Sun. It also has a companion star for easier identification. This binary star system is a very strong source of X-rays and is considered the first major evidence to prove the existence of black holes. It sits approximately 7,000 light-years away from us. The fact that scientists discovered something so far away in the early 20th century is by far the most interesting thing scientists have found. Fast forward to the 21st century, we've discovered over 100 million black holes within the Milky Way galaxy. Since these things are invisible and a lot bigger than the Sun, their existence is a terrifying thing to consider in the cosmos. Now the question that was on every researcher's mind was how these things form in the first place. Since there's no life, gravity, or air in outer space for basic chemical reactions to occur, how do black holes appear in the universe? There are generally two pathways that scientists have studied: stellar corpses and direct collapse of gas. Stellar black holes are born from the remnants of massive stars that slowly lose all the energy in them and collapse under their own gravity. Direct collapse of gas, on the other hand, can lead to the formation of more massive black holes, most of which are supermassive ones. Now there are two different pathways after gas clouds collapse under their own gravity. The first pathway of cosmic evolution begins with the life cycle of a massive star. The initial masses of these kinds of stars are around 8 to 10 times that of the Sun. When stars shine brightly, they fuse hydrogen into helium in their cores. Once the nuclear energy finishes, it collapses and triggers a catastrophic event known as a supernova. Here, the outer layers of the star are released into space in a violent explosion. And because it's outer space, where you can't really hear anything since sound can't travel there, these supernovas could happen without you even noticing it. Once the supernova occurs, one of three things is formed: either a neutron star, a white dwarf, or, if the star is massive enough, a black hole. Believe it or not, if a supernova occurred as far as 65 light-years away, the cosmic rays and aftermath would risk humanity as we know it. At least 30% of the ozone layer all around the planet would be completely destroyed, 87% of it would be destroyed in polar regions. Coming toward the second pathway, the direct collapse of massive gas clouds skips some of the stages of star formation. In regions of space with high densities of gas and dust, the different gravitational forces can cause clouds to collapse as well. The difference here is that a protostar is formed. In some special cases, the gravitational forces are so strong and intense that even a protostar isn't formed. Instead, the gas cloud collapses and directly forms a black hole. Another question that's often asked is how long these entities last. Do black holes lurk in distant galaxies forever, or do they eventually die and leave something much more terrifying? Well, when they form, they can live for potentially billions or even trillions of years. Their gravitational pull has been felt at every corner of the universe for a very, very long time. With this pull, they draw close gas, dust, and even stars. These things are usually drawn in groups and clusters, which eventually form a disk. So what happens when the so-called disk exists? Think of it like a Death Star that shoots high-energy radiation like X-rays and gamma rays. But that's what happens to the things around the black hole, right? What happens to the actual black hole? Many scientists believe that black holes are considered to be eternal. Once they're formed, they'll exist forever. The only thing that slows them down or makes them fade away is the emission of all those gamma and X-rays from the makeshift Death Star. Stephen Hawking helped coin this theory in the 1970s. Hawking radiation was named after a brief quantum study of black holes. As the Hawking radiation is emitted over time, the black hole slowly loses mass and eventually dies. Let's talk a little more about Hawking radiation to get a clear picture. These come from quantum fluctuations near the event horizon, where pairs of particles spontaneously pop into existence. To make things simpler, think of these particles as bubbles in a fizzy drink. They appear out of nowhere, completely unpredictable. They also come in opposite pairs called antiparticles. When they meet, they cancel each other out and disappear forever. It happens so fast, it's as unpredictable as them appearing in the first place. Sometimes they'll appear on the event horizon, and if one of them falls into a black hole, the other escapes into space. Because of strong gravitational forces, the one that's trapped in the black hole, though, has some of its energy stolen from the void itself. The stolen energy piles up, which causes the black hole to lose its mass. In a nutshell, this process is what we call Hawking radiation. So black holes aren't just for swallowing anything within their vicinity, they also release this Hawking radiation. The phenomenon helps scientists understand the lifespan of a typical black hole. The smaller the mass, the more rapid the Hawking radiation and the shorter the lifespan. It also helps scientists differentiate between black holes and wormholes, because these two behemoths of space aren't as similar as one may think. The concept of black holes and wormholes, unlike black holes, which are regions of intense gravitational force, wormholes are hypothetical tunnels in spacetime that connect two distant points. Now, this may sound very fictional and something you'd see in movies or hear in storybooks, but scientists are trying their best to figure out their existence, and they seem to be making breakthroughs year by year. It all dates back to Albert Einstein's theory of general relativity. Scientists have been studying these things since what feels like the dawn of time. Einstein published his theory in 1915 and expanded it 10 years later. His theory suggested that relativity argues with the concept of space and time being unrelated to each other. So by definition, a wormhole is considered to be a tunnel from one place in space to another. If you were to place an object in spacetime, it would create a curvature of the spacetime in the nearby region. This theory has been used in many science fiction movies, but the problem is that scientists have never proven its existence. Black holes, on the other hand, have been found and photographed using event horizon telescopes. The theoretical entry of a wormhole is two-sided. Again, they're similar to tunnels with one way into a different point in space-time. Black holes have an event horizon. This means that if something enters this region, it's stuck in the black hole for eternity. The only similarity between black holes and wormholes is the influence of different masses. The mass of the object affects the size of the curvature in spacetime in the case of wormholes, while it affects the energy released from black holes. NASA might end up making a telescope specifically for wormholes, just like the Event Horizon Telescope. This depends entirely on how technology will change in the future. We've already launched a telescope that can basically turn back time. Yes, the James Webb Telescope has made some very interesting discoveries that will blow your mind away. The possibility of an image of a wormhole would change the course of astronomical sciences forever. But as far as space discoveries go, wormholes are unfortunately out of the question. What was discovered, though, is something that blew away many scientists all over the world. But before diving into the specifics, you should also be familiar with some of the black holes that have already been discovered. The first black hole captured, Messier 87, also known as M87, is probably one of the most interesting discoveries made to date. It's actually a supergiant elliptical galaxy in the constellation Virgo containing trillions of stars. It's also one of the most enormous galaxies in the universe, 55 million light-years away from us. M87 also emits radio waves in the universe. It's no wonder why astronomers are enchanted by something so magnificent. It was first acknowledged by Charles Messier in 1781. The technology of this era was almost non-existent to make any detailed observations, so M87 wasn't fully understood until much, much later. 2 centuries later, Heber Curtis observed a jet-like feature in the core of M87. This was the first identification of an extragalactic jet. What's an extragalactic jet? It's like a stream of radiation emitted from the center of a galaxy. And what's one of the things that emit such radiation? Yes, black holes. While researchers couldn't exactly tell what this jet was at the time, it was by far the largest stream of radiation ever discovered. In 1947, the first radio signals were detected from M87, so scientists got to work on gathering as much information as they could from this particular entity. Now that we know how far it is from us, scientists wondered how far the black hole was from the center of M87. Later, it was found that the core contained 6.6 billion times the mass of the Sun. The supermassive black hole was 3.5 times heavier than previously anticipated. The next question was how they could photograph something so big. If you weren't already impressed by what was discovered, wait till you hear what it took to make this photograph possible. The Event Horizon Telescope, EHT, was an international collaboration to achieve a goal that was impossible at the time, taking a photo of a black hole. The EHT brought together 8 different observatories around the world, combining their imaging power to create a virtual Earth-sized telescope. Why was this done? Because black holes are extremely difficult to photograph, so scientists needed an Earth-sized telescope. This is where things get more interesting. The project started in 2012 with numerous preparations. This included aligning and calibrating all 8 telescopes located in places ranging from the United States to Antarctica. They used very long baseline interferometry, VLBI, to synchronize all 8 to create an unprecedented image. VLBI is a technique that uses multiple telescopes to act as one. When a distant radio source is observed simultaneously by these telescopes, the data gathered is time-stamped using atomic clocks and then combined to simulate an enormous telescope. The VLBI was essentially a tool to piece together all the scattered data to create the image of M87. This process took years. In 2017, the EHT achieved this feat, and the data collected was analyzed by hundreds of scientists globally. But this was just the start. The photo was taken, but the real journey of creating it had just begun. 2 years later, in April 2019, a milestone in the field of astronomy was achieved. The world witnessed something unimaginable as the photo of M87 supermassive black hole was released. It was a historical event that blew everyone away and changed the perception of black holes forever. It's not every day you see scientists teaming up and working together on something of this magnitude. The EHT image captured showed a dark silhouette with a bright ring surrounding it. The dark region, also called the shadow, was caused by the black hole's event horizon, which traps light and matter that crosses it. The bright ring was formed by the bending and heating of the surrounding gas and dust due to the intense gravitational forces. The image was an incredible achievement not just for astronomy but for the entire scientific community. It proved that black holes were real, observable entities. The data obtained from this photograph allowed scientists to test Einstein's theory of general relativity on scales previously unimaginable. But the photograph of M87 supermassive black hole was only the beginning. The EHT collaboration has since continued to observe other black holes, hoping to unravel more mysteries of these cosmic giants.